All right, today is Wednesday, March 18th. The plan for the rest of the week, it's Thursday, March 18th. The plan for the rest of the week is today I'm going to go over as much of chapters 14, 15, and 16 as possible. Ideally, all three chapters. We'll see. We're not really in any hurry. And tomorrow I'm going to go through an example or two talking about inheritance and interfaces. Okay, we'll take a look at some of the examples that are in the book. We'll talk about some kind of classic examples that are out there when you start talking about inheritance. So chapter 14 is on inheritance. When we get done with that, we'll take a break, and then we'll go over chapter 15, which talks about interfaces and generics. And I want to concentrate more on interfaces. And then we'll go into chapter 16, which is a very short chapter. And I think I mentioned this to you yesterday, but much of that material we've already covered because they talk about, for example, how to create a class library. We've already done that. All right. So, as it says, inheritance is one of the key concepts of object-oriented programming. Now, when you think about inheritance, okay, I'm going to tell you this. It's not. I don't think it's particularly funny, but I remember as I've got three daughters, and all three of my daughters are adopted. And I remember once, a long time ago, I had a friend who didn't know that we'd adopted. And my youngest daughter was, I think she's attractive now, but she was a very pretty baby. And a friend of mine saw her once and said, "Wow, she's really cute. Is she adopted?" And I said, "Yes." And you can see how embarrassed he was, because he didn't mean anything by it. "Well, I'm sorry." "No, it's okay. It's totally fine." The point is this. Typically, if two people, let's just assume, I'm not going to be politically incorrect or correct or anything else, but let's just assume a man and a woman get married and they have a child. There is at least a fairly good chance, if the man has a big nose and the woman has a big nose, that the child will eventually have a big nose. That doesn't always happen, but typically that's how inheritance works. All right? And it's not like, so what can the child do about it? Well, when you think about it, two or three things. One is they can live with that big nose. All right. Second, they can probably have a nose job, but it's not like they can grab that nose and take it off and put another one on. But that is what you can do with inheritance in a programming language. Because with inheritance in a programming language, what happens is you inherit everything from the parent. But if there's things in there that you don't like, you can override those and make them do what you want them to do. All right. One of the things that we'll hopefully look at, I haven't done it yet, but I'm hopefully going to do it tonight, is we'll start talking about tomorrow an employee class. We've talked a little bit about this. And when you think about it, let's just assume, let's keep it real simple. Let's assume that an employee who works for any company has just got a few things in common. They both have a first name, or they all have a first name, a last name, maybe a department name, and an employee number. All right, but let's just assume it's a really big company that employs all sorts of different kinds of people. And let's suppose that it has four main types of employees: hourly workers, piece workers, salaried workers, and commission workers. I think you'd agree that there's a pretty good chance that all of them would make money at the company, but they would all earn in different ways. So quite often what you'll do is you'll create what's called a base class, kind of a parent class called employee, where you would have basically the first name, the last name, the department name, and the employee number. And then based off of that, you would make child classes. So you could have a child class, and you could have, for example, one child class for hourly worker, another child class for piece worker, another child class for salaried worker, and another child class for commission worker. They would all earn money in a different way. Now, we'll talk about straight inheritance in this chapter. When we get done, we'll go over chapter 15. And it'll kind of be similar to some of the stuff we talk about now. I just mentioned to you that you could create a parent class called employee, and you could, and you typically would. But what you'll see in the next chapter, not in this one, but in the next chapter, is typically when you create a very general, generic class like that, you make that class what's called abstract. What that means is you cannot create instances of that class. All right? But you create instances of the child classes. So you'll see that. And what I'd like to do, hopefully I can get this done by tomorrow, is I want us to do three things. All right, number one, I want us to go over the Chapter 12, the Chapter 12 written test. All right, number two, I'd like to give you an employee example that uses inheritance. Then number three, I'd like to make some changes to that employee example. And instead of having it use straight inheritance, all right, have it use interfaces. If we can get through all that stuff tomorrow, and believe me, it's not really probably going to take as long as you might think, then the rest of the period will be lab. And then also tomorrow, I'd like to talk about your homework, which will be your last homework before break, of course. So remember, we have class next week. All right, if you don't realize it, tomorrow's day 50 out of 80. All right, so we've got 5 more days after tomorrow, or 6 including tomorrow, whatever way you want to look at it. And then we have break for a week, and then 5 weeks when we come back. My hope is that when we come back, we will be concentrating almost solely on databases. I'm going to introduce databases to you, hopefully, a week from tomorrow. If we don't get there, we don't get there. Then we do it after the break. All right? But like I said, I'd like to do that before the break. The other thing, and I've got to remember to do this, maybe since you're all hearing it, you can remind me, especially you 3 new people, I created all accounts for all of you. You can now get to the Rankin server. And I'm going to show you how you can do that. You've got a test file up there. Literally right now, that's all you've got under your account. So if you bring it up, it's just going to say this is a test. That's it. The rest of you from last semester, if you remember, you've got your stuff out there. All right. And you're going to be asked to start working on, because by the last day of class, and hopefully by the day before, you're going to have finished your electronic portfolio. For you new people, since you don't have experience with HTML, JavaScript, CSS, etc., Bootstrap, etc., I'm going to show you a free package that you can download, which is a drag and dropper. All right, and you can use that to create your electronic portfolio. All right, that said, let's get into it. Years ago, when I decided I was going to move here, I started looking for jobs. And this one at the time was not open. They did not have this program here. All right. But they were asking for they said full-time / part-time instructor at St. Charles Community College. And I knew nothing about it. I'd never even set foot in Missouri before, but I applied for the job and I got a phone interview. All right. And literally it was over an hour long. And the way they started was, okay, Mr. Scott, what do you consider the pillars of object-oriented programming to be? And we talked about it. We talked about abstraction and encapsulation, and we've talked about that a little bit in here. We talked about polymorphism, which we'll get to in a bit, and we talked about inheritance. All right? And I even gave them some of the examples I've just given you about the fact, having male big nose, female big nose, etc., and how you can change it. But as it says, it's considered one of the pillars of object-oriented programming. Notice what it says here. It lets you create a class that's based on another class. All right? The class that you create originally is typically referred to as the parent class. The child that you create off of that is typically known as the child class. But it goes as a lot of different names. When we get into the next chapter and we talk about abstract class, quite often the parent class is abstract. And then the child class, which you can create instances of, I don't know how it got this name, but it's called a concrete class. All right. Sometimes, okay, it's called, the parent is called a base class, and you'll see that in here. Sometimes the child class is called a derived class. It depends on the book you read. It's really not that important. All right. Now, the idea, as it says here, is When used correctly, inheritance can simplify the overall design of an application. All right. The problem is over time, most people don't know how to use object-oriented programming correctly. I've been guilty of it. Have the examples that I've given you been great? No. All right. Now, next week, sometime, even if it's Friday, my hope is that, Adam, you'll have taken the test by next Friday, or you'll take it next Friday, whenever. But we're going to go back and look at what I did was I grabbed one of the test problems. I don't remember which one it is. Otherwise, I'd actually tell you. I don't remember. But I created it originally, no object-oriented programming whatsoever. Then I went back and recreated it object-oriented so you can see the difference. Now, I'm not going to lie to you. When you look at it, you might think there's not really that much difference to it. All right? And there really isn't. But the idea is the better that you can create classes, and it's kind of like, I've said this before, it's kind of like writing an outline. If you remember when you learn how to write outlines, for me, that was maybe 4th grade, and then you did book reports and stuff like that. And what did you do? You, believe it or not, you were starting to learn to modularize. You had very generic things like Roman numerals that were very general. Then you got more specific with A, B, C, D. Then you got more specific with 1, 2, 3. Well, in much the same way, if you can imagine, I'm going to draw it, even though not everybody's here, that let's suppose I created a class and I called it vehicle. And underneath that, I'm going to just create cars, trucks, motorcycle. If I wanted to, I could even put in here bicycle. All right. All vehicles have something in common. So what you try to do when you come up and start to create an inheritance, a hierarchy like this, is you want to take as much commonality as you can and put it as high up in the hierarchy as you can, because then it's automatically included down here. Now, when you think about it, for example, just as an example, trucks, you could have like 18-wheelers or whatever, and then you could have, just like standard trucks, just whatever. Standard, I don't know. But maybe even a better example of that, and I've shown this one, or I mentioned this one to you before, and I'm going to say it again, is you come up here and you've got a very generic bank account class. And underneath that, you've got, let's say, 3 types. One called savings, one called checking, and one called, let's say, IRA. I know there's other types of accounts as well. All right, I know there's things like retirement accounts, Christmas, I don't care. Let's just assume that the bank we're working with has these 3 different types of bank accounts. So they have savings accounts, checking accounts, and IRA accounts. I think you'd all agree there's something in common with all those accounts. You're going to have the name of the person who holds the account, etc., a lot of different things. But savings and checking can be totally different. Typically, with a savings account, you're earning some kind of interest. That's why you're putting money in savings. Checking account, you may get interest, you may not. There may be different types of savings. There may be different types of checking. There may be different types of IRA accounts. So you start bringing them down. So for example, you might have for checking, you might have both an interest-bearing checking account and a non-interest-bearing checking account, something like that. As you work your way down, this right here is actually known as a level 2 hierarchy. Remember, since we're computer people, we start counting with 0. So that's level 0, that's level 1, and that's level 2. All right, and this can go down as far as it possibly can. So again, the idea here is this would be everything you put into a bank account class that would be common to any kind of account, whatever it is. This in here would be stuff specific to a savings account, stuff specific to an IRA account. Here we would try to put everything that every checking account would have, and here would be the different stuff for interest-bearing and non-interest-bearing. And if you start to understand that, that's the key to starting to be able to understand all of this. All right? And you can literally go down as many layers or levels in here as you have to or need to get down. And the idea, again, is the more complex the operation, the further down and the more levels of inheritance, and the bigger the hierarchy, for lack of better words. All right, so we'll look at this in a minute, but it says 14.1 illustrates how it works. When it's used as it says, the derived class, also known as the child class, inherits all the properties, the methods, and other members of the base class. All right, it says it can also provide its own members to extend it. And it can also override any properties or methods, okay, that was passed to it by the parent or base class. All right, so the example that they show in here, as it says in the example here, they're going to use the Systems Windows Forms class. So let's take a look at what they've got here. All right, so if I create a class right here, and don't even worry about system, this, but if we got a parent class here, and we create these variables in here. So a variable called text, one called minimize box, one called maximize box. All right, close, show dialog. What that says is everyone who inherits from it automatically gets that stuff. And then typically what it's going to do is it's going to add its own stuff. Now it can go and override anything that's in here. That's the idea, like I told you before. If you don't like the nose you were given, you could take it off and put on another one. Now, I know that's not the way it works in real life, but that is pretty much how it's working here. All right, and that's what they're talking about. So as it says, it allows you to create a new class based on an existing class, which inherits the properties, methods, and other members. There are some caveats to that we'll look at as we go along. The different names I've mentioned to you already. All right. So when you want a class to extend or be a child of another class, you're going to use a colon. So you're going to have like public class, the name of the class, colon, and the class that it's inheriting from. Now, just so you're aware of it, in the fourth semester, you guys will be taking Java. Java doesn't use a double or a colon, it uses the word extends. Every language is a little bit different. So as it says here, when you create a new form in C#, the form inherits the .NET Framework class. So everything that's available in here is now automatically available to you. And that should make sense to you, and that should be a good thing. The idea is, if I go and create a form and then create a form off of that form, etc., they can all use buttons. They can all use labels and text boxes, etc. And they all have events that pretty much work in the same way. All right. Okay. So they mentioned here how the .NET framework uses inheritance. All right. As it says, it's used extensively throughout the .NET framework, and they're going to show you a little bit of it in here. Now, you may find this easy to look at and understand. You may not. But you kind of got to look at it this way. All right. And I don't know how much experience, hard work type of experience any of you have. It's kind of irrelevant here. But if I go in and I bring this up, if I go in and type in CMD, I'm bringing up a DOS window right there. Does that make sense to everybody? And if I type in CD to /, I'm at the root. I'm at the root level. I can't go up any higher than that. All right, that's the top, that's the big cheese, whatever you want to call it. That is literally the only thing that doesn't have a parent. Does that make sense to you? The reason I'm telling you that is that's object here. Everything that you've done so far inherits from object. And you could have, if you wanted to, when you create a new class, you could say colon object, which means inherits from object when you create a new class. Not one that's off of another existing class, but one that you're creating on your own as a base class. People don't do that because that's assumed. So the control class is right off of object. So it is a direct descendant of object. All right, then you start to look at what else is in here. Well, think about what this means. Every single object All right, in fact, let's just take it here. Every control that you create has things in common. They all have a name property. All right, they all have that tag property that we've looked at, and there might be a few other ones. All right, in addition, whether it's a regular button or a checkbox or a radio button, they all share things with buttons. All right, so again, the idea is we take as many things, as much commonality as we can have here, and we pass it down to here. Then we take as much commonality as we have here, and we pass it down to here. All right, now when you look at this, this is actually pretty simple, because that's really level 0, level 1, level 2, level 3. And they really don't go down any more than that, except for the form right here. All right. So, as it says, the .NET framework uses inheritance extensively in its own classes. That was what we just looked at. All of the control classes are derived from the base control class. All right. Now, it's going to sound a little strange, but after the break, one of the first programs that we're going to create is going to, I'm looking for the right word, it's not coming to mind right here, echo, we'll just say what a database is, but it's not going to be a database. It's just going to show you the kind of stuff, because it's going to give me the chance to show you some of the stuff that's in this control class that we haven't hit on. And the main reason we haven't hit on it is it hasn't been in the book. And some of it will be in the book. Some of it I'm just going to give to you. All right? Okay. As it says, all control classes are derived from the base control. That's what we just looked at. Tag and text, as I mentioned, those are at least two that every single object from there has. All right? Some controls have an additional layer of inheritance. And that's what we just looked at. Now, the fully qualified name of a class means that you put the class name dot something. You're going to see that more and more as we go on. And you might think, I don't know what that means. Yes, you do. If you remember, one of the first things that I showed you when we started creating console applications was that using static system.console. All right. You wanted to use the system class. All right. And underneath there, you wanted to use the console class. And underneath that, you wanted to use the read line or the write line method. So in ways, at least, you've already been using this. We've been saying stuff like the name of your text box dot text equals double quote, double quote. And we've done that kind of thing to clear out the contents of a text box. What does that mean? All right, that means that you've got an object of the text box class, and you've been using one of its methods. All right. So we'll see more and more of this fully qualified name stuff as we go on. Now, what do you get? Well, believe it or not that much. I'm going to make this, it's not going to let me make it much smaller. Let's see. Well, no, I don't want that. But if I bring this up, let's see. Oops. This is the stuff that you get, as the saying goes, out of the box. So in other words, okay, these are the methods that are available to you from the object class. So anytime you create something, you automatically get a toString method. That toString method works in a certain way. That's why, as an example, if you remember, we've overridden toString already in our classes. All right. You get an equals method. Notice what it says. It returns true if this object refers to the same instance as the specified object. So what that says is, do we have two things pointing to the same thing? It doesn't say, do we have two objects that have the same data? It says, do we have two things that are pointing to the same area in memory where that data is being held? All right. So and as it says, there's a static version of this. I don't want to get into that right now. All right. Then there's a reference equals. And as it says, whether or not two object references refer to the same instance. Remember what a reference is. We talked about pass by value, and we've talked about pass by reference in here. When you pass by value, you pass a copy in. So any changes you make are made to the copy. When you pass by value, you are sending in the address. So any changes you make are permanent changes. All right. There's a GetType. Returns the type object that represents the type of the object. Can be important. There's a getHashCode, which we're not going to really talk about at all in here. That I'm not saying that's never used, but that would be used more probably if you were doing system type of programming for operating systems and the like. We don't do that in here. We do application programming. All right. There's Finalize. What Finalize does, as it says, is it frees resources used by an object. It says this method is called by the garbage collector. What the heck is that? Well, every Friday morning at the Scott household, the garbage men come, or garbage people, whatever you want to call them. And what do? Take the garbage and they dump it. The difference is here, the garbage collector is something that runs under the operating system. And what it does is it checks different programs and it says, hey, do you have any memory right now that you're not using? But it doesn't typically do it exactly like that. Now I'm dating myself with what I'm about to say, so if you don't know what it is, it's fine. But years ago, I was a student at the University of Wisconsin-Milwaukee. All right, and all over the place in there, they make it difficult because some classes are more than 2 hours, but everything around there is 2-hour parking. So you'd find a place to park, you'd get out of your car, you'd go to class and you'd pray to God that when you got back, it wasn't 2 hours and 10 minutes and they hadn't found you. All right, how did they find you? They literally had meter-maid people that would come by with a piece of chalk, and they would put a piece of chalk behind, on the back tire of your car. And when they came back later, if that piece of chalk mark, the chalk mark was still there, you got a ticket. Does that make sense? In much the same way, in most typical garbage collections, the way that it works is the garbage collection comes and it says, oh, this isn't being used by this program. So it marks it as being unused. Then when it comes around again and the operating system process comes around again and it says, oh, yeah, it's unmarked and we'd already flagged it, then it gets rid of it. But it could mark it because it's not being used, but then in between the time that it marks it as being used and the time it comes around again, it could now be being used. It would be like me moving my car so that chalk mark would disappear. It's the same type of an idea. All right. Now, Finalize goes by different names in different kinds of programming languages. All right. This is similar in here to what's typically referred to as a destructor. Remember, we've talked about constructors? There's also a destructor. What does a destructor do? It typically frees up resources you're not using anymore. All right. As an example, when we start working on databases, we will be using the equivalent of destructors. We will be telling the system to dispose of things that we've been creating so that we could do our database work. Why? Because they're not being used any longer. All right. And that memory can be freed up because it's not being used anymore. All right. I'm not going to sit and read this stuff to you. If you want more than what I gave you, all right, you can take a look at it in here. Notice in here it says you don't typically need to override the Finalize method. You typically do the work in other methods. And we're going to see that, again, more so after the break than in here. All right, what we're doing now. All right, how to use inheritance in your own applications. Notice it says here, the figure on the next page is going to show you two main ways inheritance is used. First, as it says, it can be used to simplify the task of creating classes that represent similar types of objects. What they're going to do is this. I'm not even going to go to here. I'm going to go ahead a little bit. Let's see if they show it. I'm pretty sure they did. I know I'm jumping up quite a bit. We'll go back. All right, there, that's what I want to show you, is right here. They're going to create a generic type of product class, something that all products have. Now look on the screen if you would, please. The thing that differentiates these two forms that you see right here is in here, the radio button is for book, and in here, the radio button is for software. But you'll notice that in both cases, they have a code, they have a description, they have a price. So what's different about them? Books have an author, software has a version. But the idea is if up in our product class, we can sit there and say, hey, what do all products have in common? We can take the stuff that's in common and put it up there and push the stuff that's specific to a particular product down. All right? And again, you're going to see that in more depth and breadth of coverage as we get into this. Sometimes I just think it makes a little bit more sense to actually see a picture of it than it does to try to explain it to you. All right. It says the second inheritance hierarchy shown in this figure shows how you can use .NET classes as basic classes. Haven't you done that? Haven't you already created classes based off of the list class? Haven't you already created the different stuff based off of the array class? All right. So here's what they're showing. Now this is what we just looked at a second ago, but you'll notice all three of these, so this is the parent, but all three of them have a string for the code, a string for the description, a decimal for the price, and they all have a getDisplayText method. So what differentiates these is this one has a string for the author, this one has a string for the version. So again, we can encapsulate or put everything in common that we're assuming that every product has these four types of things. And then we can go and create different subclasses underneath this, and each subclass has what differentiates them from the other. In this case, an author versus a version. All right. And in this case, what they're showing is, okay, this is what you get by default from the system collections generic, but you can go in and add your own stuff. Or you can take something that you've got added to you and you can modify it to whatever it is you want it to do. So as it says, you can use inheritance in your app to create generic base classes that implement common elements, or you can create classes that inherit from predefined classes or defined classes in the .NET framework. All right, so what do you need in order to be able to do this? So this is, as you can see, basic skills for working with inheritance. Well, the first thing is you need to understand how to create a base class. So again, for that product class that we just looked at, you've got to be able to sit there and think and say, okay, I mean, when you're starting to create something like this, so let's assume that's a company. Now, is that going to always work? You know, is your product class going to always work that every product will have those four things? I don't know. All right. When you think about it, there are a lot of companies today that don't just sell physical, tangible products. They also sell intangible products. They may sell advice or something like that. Okay. So I don't know. But as it says, to start with, you define the properties, the methods, and the other members of the class just like you would for any other class. Then, if you want the class that's derived from this, all right, it says you include the virtual keyword on the declaration for that member. You're going to see this in just a minute. It says the code shown in this figure, for example, uses the virtual keyword on the getDisplayText method. Members that specify this are typically called virtual members. Half the battle in using this stuff is just being able to put in the correct terminology. All right. So as it says, this table also lists several access modifiers. All right. And it's going to introduce one you haven't heard of before. We've talked about public, and when something is public, it's available within the class. It's also technically available outside of the class in which it's defined. We've also talked about private, which means it's only available inside of the class in which it's defined. What we've seen so far is, most of the time at least, we've made our data we've made our data private. We've made our methods public. All right. One method that's always got to be public is our constructor. All right. There's also a third part in here, or a third type. There's actually more than that. But the third one is called protected. All right. And with a protected class, again, if you remember, if I go up here, going back to the example I gave you before, I'm not going to redraw the whole thing. But again, if I've got a bank account here, and underneath that, again, we said savings and checking and IRA. Typically, if I go, I'm gonna usually take most of my data up there in my bank account class. I'm gonna make it private, and I will have getters or whatever. They'll be able to look at it and maybe even change it, but they have to use the stuff I've created up here for it. All right. Well, the point is, if I take a piece of data where we've always said something like private, int, age, something like that. That means that the only way that I can change this, so if later I make a setter and I make a getter for age, the only way I can change those is by using the setter and getter. Does that make sense? All right. If I were to make it public, anybody could change it anywhere. Again, you never really want to do that if you can help it with data. But let's assume that I may have to change age, which is a crummy example, but in one of these. Let's just assume I may have to change it. Then, instead of making it private, I can make it protected. And what protected means is the parent can change it, and so can any of the children. All right? I mean, in a nutshell, that's pretty much the way that it works. There's also internal and as well. All right. And as it says, internal typically has to do, you're making it available to everything inside of the project in which you're working in. All right. That one, I'm not going to say it's never used, but it's not used as much, in my opinion, as the other ones. Now, if you look in here, notice, so what they put in here is public virtual string get display text. So these are the different levels. We've talked about public in the past. We've talked about private in the past. I just mentioned protected to you. All right. Now, we don't typically in here have to worry about the current assembly in which we're working, our current work area, so to speak. So I'm not going to talk about the internal or the protected internal. All right. So as they mentioned, you create a base class just the same way you create any other class. You have to really start thinking, though, about access modifiers. What do you want to make public? What do you want to make private? And is there anything in there you might want to make protected? And that's what they're saying. I'm not going to sit and read this stuff to you. All right. Now, the only one I will mention is, again, this one. If you want to be able to override a method in a derived class, you must include virtual. Think about why they did this. All right? Because in here, you may want to write out the information for a book differently than the information for software. What do I mean? Well, for the book, you want to add the author name probably to this get display text. For the software, you want to maybe add the version number, or there could be other information that you want to add. All right. That's why, again, it needs that word virtual here. And you say, well, we haven't used that before because we haven't used inheritance before. All right. So how do you create a subclass? And again, a subclass, also known as a derived class, also known as a child class, is a class based on a class. As it says, you follow the class name with a colon and the name of the base class. So public class, child class name, colon, parent class name. Okay, that's it. There's nothing more special about it. All right, it says after you identify the base class, you can extend its functionality by coding, adding additional properties, methods, etc. So they're going to show an example. Now, you'll see this in just a second, but notice that get display text, which we originally made virtual that you saw, it says it includes the override keyword. So if you're saying you do want to override it and change it, and you can because it was virtual, all right, you use the word override. And you're going to see that in just a second. Lastly, in here it says, this figure also introduces the concept of hiding. When you use the new word on a subclass member, it hides the corresponding base class member. As a result, the subclass doesn't inherit the original version of the member, but it makes a brand new one. And it gets a little bit hard to understand after a while. And we're going to even hit another word before the break here that's called polymorphism that you're going to see in just a minute. All right, so let's take a look at the example. So again, this is how you do it. Public class, child class or subclass or derived class name, colon, base class or parent class name. All right. Now, it says to create a constructor, this is really important, so please look at this. You're going to be using the word base. So, again, the reason that this is important, you're going to see it in just a bit, is what we're going to tell a book is, hey, you've got a description, a code and a description and a price. I'm going to let the parent handle those. I'm just going to handle the author. Then you've got software. And again, with the software, you're saying, hey, I'm going to let the parent handle the code, the description, and the price. I'm only going to handle the version. All right, so that's exactly what you're going to see in here, right there. So notice this says, I'm making a book. Now, usually when you work with inheritance signifies what are referred to as is a or is an relationship. In other words, a book is a product. Does that make sense? Software is a product. So this is one of those. You'll notice we're creating one new variable, just an author. Everything else is created from the parent. All right? And what we're saying in here, this is our constructor. This hasn't changed. This is still our constructor. But we're saying to the constructor, colon base, we're saying, hey, go to the parent and call the getter or the setter or whatever you have to call. You handle the code, the description, and the price. All I'm handling in here is the author. And what you want to make sure you always do this first, and you do this inside of the constructor. Now, for example, I'm just telling you, in Java, you do it a little bit differently. In Java, you don't put it in the constructor here like this, but the first line in the constructor is the word super. And you put in what you want there. And then that means you pass that stuff up to the parent. But it works the same way. All right. And notice they needed the word override here. And what are they doing? All right. Still got the code, still got the description. This is what they're adding. That author. All right. You can put it anywhere you want. When you're overriding something, we could have put author first. We could have put author last. It doesn't matter. But we're saying is, hey, when it's a book and you want to print it out, display the text, this is the way we want it to show. All right. And they do mention, again, you could use that fat arrow syntax that we've talked about before. So you can do this in different ways. This one's kind of neat. In this one, you're saying call everything from the parent, and then on the end, add the author. So if you don't mind just using what you get by default from the parent and just adding what you want to add to the end, it's a faster way of doing it. It's not as customized. But notice you still need the word override in there because you are changing the original. All right. So again, the base keyword is used to refer to the base or the parent class. The override is used to override a virtual member. Okay. Now the next thing is polymorphism. I'm going to show another drawing up here really quickly because it's the one most people use with polymorphism. Okay. So let's say that I come up here and I create a class and I call it mammal. And I'm just going to create 3 classes over here. I'm going to have a dog, I'm going to have a cat, and I'll just put it, I don't know, dog, cat, how about a bird? All right. Now, one thing that I can do is I can declare a method up here, a generic method that's called speak. I can have it do whatever I want it to do. Are you with me? All right. But I can come down here and I can override that speak method. And if it's a dog, I don't know, maybe woof. And if it's a cat, maybe meow. And if it's a bird, I don't know, maybe chirp, whatever. But the idea is this. Based on the type of object that you're working with, based off of that class, it can call the same method and it knows to do different things with it. Does that make sense? If you think back to the bank account class, you might have a method up here called calculate interest. You might calculate interest different for a savings account versus a checking account versus an IRA account, etc. All right. So polymorphism, literally, it's a Greek term that means many forms. All right. And it just means, in this case, it means that literally different types, different objects of different classes can respond differently to the same generic method. All right. Now that's my definition. I'm not going to read what's in the book. You can take a look at that. But it pretty much says the same thing. Notice, lets you treat objects of different types as though they were the same type by referring to a base class that's common for both. So again, we've already started to look at this stuff. You'll notice that whether you're creating a book or you're creating software, what's the difference? The difference is in a book, you've got this, which is the author, and in software, you've got this, which is the version. Other than that, you are creating them the same way. All right? So you'll notice it says here, so we're creating a book that's called B and software that's called S. And notice we create a product, a generic product that's called P. And you can take, and that product can be either a book or that product can be software. And when you call the get display text, it calls the one for book or the one for software. So it knows the right one to call automatically. All right. So you can read this. I've tried to hit the high points with you. And on the very bottom here, it says, polymorphism is most useful when you have two or more derived classes that use the same base class to allow you to share things. All right. All right, so the next thing they're going to do in here, we'll start on this and we'll take a break pretty quick. But as it says, an inheritance version of the product maintenance class. All right. It says this version of the application uses the classes that were described earlier. It works with a products file that holds two types of products, books and software. It says, note that this version won't work with the product DB classes that'll be presented later because that stuff hasn't been implemented yet. But, all right, it says that the figure on the next page shows the operation. It says there, the product maintenance form looks just like the one we saw earlier, except it's now again going to have on it those two radio buttons. And it says, what do you want to create or instantiate? Do you want to instantiate or create a new book object? Or do you want to instantiate or create a new software object? All right, and then based on which of those radio buttons you click, it's going to bring up a different form. All right. So notice if I want to add a product, okay, it's going to have to know what kind of product do I want it to bring up. All right. It's going to have to know, will it be a book or will it be, other than that, it's going to work the same as what we saw before. So as it says here, it handles the two types of products. The new product form has a radio button that lets the user create a book or a software product. The label for the third one here Either author or version will change depending on the option that was selected. These are, I believe at least, all right, I think the way they've set this up is these are two different forms. Just be really leery, because I've seen people do this. Oh, wow, object-oriented, this is great. They write such convoluted logic that it doesn't make a whole lot of sense. You may have heard of the word obfuscate. All right, that's not a hot word, but it's a word that's used quite often with IT and different stuff in here. And if I look at it, it says to confuse, bewilder, or stupefy, to make obscure or unclear. And that's what, quite often, unfortunately, that's what a lot of people do when they write code like this. They try to combine stuff together that really and truly shouldn't be so much combined together. All right. I've mentioned to you, I've given you examples of this before where I've said things like, as an example, that if you were entering, let's just say 6 pieces of information, first name, last name, address, city, state, zip, just those 6 pieces of information. Ideally, you should put those in 6 different methods. That said, most people don't do it anyway. A lot of times people are looking for the easiest way of doing something as possible. This is one place where sometimes trying to make something easy can end up blowing up in your face and making it a lot harder rather than a lot easier. So they will show you the code for the product, book, and software classes. We'll go through this and then we'll take a break. So let's take a look here. So here's the code for the product class. So we're saying again, all products have a code, have a description, and have a price. We put it in here, an empty constructor, but it does nothing. You can see that. You know now what that means. All right. And we've got another one that will expect all 3 of those things be put in there. Then we've got a getter and a setter for the code, a getter and setter for the description, a getter and setter for the price, and a get display text that, again, we're making virtual, meaning that it can be overridden. All right. Then we've got book. So what's new here? Well, this is new, product. Remember, this says a book is a product. So it now has everything from the product class is now available to it. But and we're adding this author. But if you look at the constructor here, not the parameterless one, but the other one, what that is saying is I can't call the getter for code, description, and price. I've got to call the parent's getter for code, description, and price because that's where they live. That's why you need the base. So to say that you're inheriting, it's the derived class the base class. And when you're in the constructor, to tell it to call the constructor's getters and setters, it's base, and you pass the stuff up. So notice how simple our constructor becomes. It's just that field. You probably have already guessed that when we look at the software in just a minute, it's going to look virtually identical to this, except this will say here, software. This will say version. This will say software. This will say, version. This will say version and version and version in here. But other than that, they're pretty much the same thing. And here we are overriding, we can because it was set up, remember, on the last page as being virtual. Since it's virtual, we can override it right here to add our author stuff on there. So as it says, the book class inherits the product class. It adds a property named author and it overrides the getDisplayText method. And then again, as I just mentioned, here's the software. And I will tell you, you've got to do this for your next test. And I'm really hoping we can get that next test done like a week from today. So right now what I'm planning on doing is giving you some lab Monday, Tuesday, and Wednesday of next week, making all 3 lab days so for you to work on the homework. And then on Thursday, we'll take the test. Friday then, what we'll do is we'll spend some time. We'll talk about whatever, but we'll also, like I said, I'd like to have everybody at that time try to get into your IWT ranking account and give you a quick little overview of what we'll be doing in the database stuff, or portion of the class. But again, notice what's new here. Software before it was book. Software before it was book. Version before it was author. Version and version before it was author. Same thing here, and here we're adding version instead of adding author. All right, other than that, it's virtually the same thing. Okay. All right, before we go on, it is 9 o'clock. Let's take 15 minutes. Let's come back at 9:15. We're going to pick it up on page 460 and talk about, as it says, the code for the product list class.